What's up, guys? I'm Pierce from SnappyData, and I'm going to show you our getting started with SQL today. Just to give you a little recap of what I went through to get to where I am here, I'm on Mac OS X, and the first thing I did was install Homebrew, and then using Homebrew, I installed Java 8, which is pretty straightforward. Now, Mac OS X comes with SSH and curl. But if you're on a different system, you may need to install both of those. And then I also set up passwordless SSH, which we have a little section here on how to do that. And it's not necessary, but pretty important. SnappyData uses SSH, and if it's set up passwordless, it just makes everything easier. At the beginning of the getting started, we tell you to export the Snappy Home variable, and I've got that done as well. So then the first thing I'm going to do is navigate to that directory. Oh, whoops. And from that base directory, I'm going to start the servers as indicated with the start script here. And while that's happening, we'll talk a little bit about the architecture. So the start script starts up three things. The SnappyData locator. The locator coordinates membership in the cluster, load balances SQL clients, failover and failback. The lead node, which manages Spark jobs, high availability for the Spark driver. It's a cluster manager for long-lived Spark executors. And the data servers, which are the core database engine nodes. They manage in-memory data, disk stores, replication, and they also co-locate with Spark executors. And in fact, that leads into a few of the ways that we've extended Spark. Two of those pretty important changes are first that the executors are long running. So normally with Spark, when you start a job, the executors spin up and then spin down when the job is over. In SnappyData, the executors are long running, and the point of this is that we want SnappyData to be an operational store. We want it to be highly concurrent, so multiple people can come in and submit Spark jobs at different times, and so you need executors to always be there to do that. And along the same lines, for Snappy to be operational, we need the driver to be highly available. So we make sure that the Spark driver, which is usually kind of a single point of failure, is highly available. So as you can see, it looks like it started up here. And you can also, now that we've got it started up, we can load the Spark console, which is blank. Oh, and by the way, I forgot to mention this. You can come in and download the preview release just by coming to our repo, clicking on release, and boom, it's right there. Okay, so the first thing we want to do is connect to the Snappy shell. It's not exactly the same as the Spark shell. I'll talk either a little later on or in a different video about how to use the Spark shell with Snappy. So that loads the shell right there. The first thing we want to do is connect to the servers we just started up. And you can see some diagnostic things here, like we can show the members. You can just see the three things that started up there. Pretty simple. And so this is a little explanation of some basic SQL statements. You can see it's pretty similar to standard SQL, and we'll talk a little bit later about what buckets 5 means. So what we've provided in the getting started is a bunch of scripts that automatically create these tables for you, just to make it easier. So we'll go ahead and run that script to create a column table. So an important thing is in Snappy is that it's both an OLAP environment, but also an Oltp environment. So we have the ability to create column tables, which are good for fast, optimized OLAP processing, but also Oltp row tables that are good for transactions. So we should finish here in a second, and then the next thing we're going to do is, oh, you know what? So this is actually, now, this is something I forgot to mention. So in the beginning here, we tell you to run, we tell you that a good idea, so SnappyData comes packaged with a set of airline data. It's about 1 million records. And the full airline data set is about 52 million records, quite a bit bigger. And so what we tell you to do at the beginning here is that you should download it, because when we get to the approximate query processing part of this getting started, it becomes a lot more interesting to see how the queries can remain interactive. And the way to do that, by the way, is from the root directory to just run this command right here, and that'll automatically download it. And then the next thing you have to do after that is you have to go into the create and load column table script that we just ran in here, and you have to change you have to change the file, which is just specified as this in that script, to point at this, which is the full directory. So I had actually done that, and so what this is doing is creating the column table over that whole data set. So it's going to take a little bit longer. But that's good, because once we get to approximate query processing, you'll be able to see the speed up a little bit more. So one thing worth mentioning, I said we'd talk about the buckets later that get specified in that create table. So the number of partitions determine the number of concurrent tasks used across the data servers to run the query in parallel. In this case, our column table was created using 5 partitions, and hence we'll use 5 concurrent tasks. So when we specified here, create table airline with the options of buckets 5, we basically created 5 partitions and what will be 5 concurrent tasks. And we will create the Oltp, or the row table. Boom, that was quick. And the first thing we want to do is run the set of OLAP queries over all that data. So this is going to take longer than it normally would, because we loaded the full airline set. Hopefully not too long. But the nice thing will be, once this is done, when we get to the approximate query processing part, I'll be able to show you and compare the time it took. So you can see this is kind of happening right now. So for example, let's see here, we just did a basic count on which airlines had the most flights, and you can see across these different years, Southwest is just killing it, and that took about 8 seconds. Which airlines arrive on schedule, we've got these are in minutes, so a little hard to tell which carrier it is, but you'll see later on, actually in the next query, how to do a join to make that more simple. So that took about 4 seconds. Which airlines arrive on schedule? So here it's same query, but we joined it with the reference table so we can get the full name. And you can see it looks like Aloha Airlines was actually better than schedule. Hawaiian. This might be, I mean, I don't actually know, but this might be because they have less flights than a lot of these other airlines. But you get a sense here of who's doing well and who's not. That took about 9 seconds. What is the trend in arrival delays across all airlines in the U.S.? So you can see on the different years, it's actually, it's kind of flip-flop back and forth. In 2015 is about 7 minutes. That took about 2.5 seconds. Which airline out of San Francisco had the most delays due to weather? SkyWest appeared to have the most problems there, and United. And that took about 3 seconds. So that actually, that was pretty fast. But not truly interactive. I mean, for truly interactive times, we'd like to see things down to a second. So let's see, the next thing we want to do is run the Oltp queries just so you can see that Snappy is both an OLAP, these are pretty common OLAP queries, but also an Oltp store. So here what we did is, let's say that the airline company Delta Airlines rebrands to Delta America. So we found that cell in the database and changed Delta Airlines to Delta America. So classic case of mutation, not something that you can currently do in Spark, but definitely a common thing in an SQL database. Okay, so now we're to the approximate query processing part. So what AQP is, it's a way for you to get an approximate answer over a huge amount of data that executes much faster than a full scan of the data would require. So in Snappy, one thing that we do to support that is produce a set of stratified samples on large tables. And so in this example query, what we're going to do is create a sample of that full data set that I just talked about. That's about 3% of the size. It's stratified on 3 columns, which is given by the group by and where clauses, and that makes up the query column set. And multiple samples can be created, and queries that are executed on the base table are analyzed for appropriate sample selection. So you as the developer don't need to know a lot about what's going on here. All you have to do is write your standard SQL query, and then you tag on a little thing that just says, hey, I'll tolerate this sort of error rate, and then you execute it, and this will go out and find the right sample table to run it on to meet that error rate, and it'll come back much faster than the full scan would. Oh, and one thing I've forgotten to mention is we can look through the Spark console here, so you can see that the airline table that we just were running queries on over here is about 1.5 gigabytes. You can see just all the same things you can commonly see in the Spark console about jobs and query execution. So that's nice. You can continue to use this with Snappy. So one of the first things we're going to do to get the approximate query processing stuff going is to create the sample table. So we're just going to run that script, and again what we're doing is running this up here. So let's go ahead and do that. Okay, that'll take a little bit. So you can run queries directly on the sample table, which is stored in columnar format, or on the base table. For base table queries, you have to specify with error constraint, which is what I talked about, indicating to the SnappyData query processor that a sample can be substituted for the full data set. So here's an example of that. So you have your basic query, and then you specify with error. The above query will consult the sample and return an answer if the estimated answer is at least 90% accurate. That's what this means here. And by default, we use a 95% confidence interval. And then you can also access the error using built-in functions. So pretty easy. It sounds kind of complex, but it's actually very easy to use. You don't have to learn a lot of statistics or anything like that. And again, if this takes too long, I'll fast forward it a little bit. Okay, so we're done there. The first thing we want to look at is the difference in size. So we've talked a lot about how approximate query processing will speed up the time it takes to execute a query. But another really important benefit is how many less resources a sample table uses. So like we said, this would be about 3% of the size of the full data set. So instead of 1.5 gigabytes, we have less than 80 megabytes. And what you'll see is that the answers are actually pretty similar. They're approximate, but very close to the original answers. So let's go ahead and run those. These should be the same OLAP queries as the ones we did above. So you can see it's just going faster in general here. So First thing we did were a couple counts. Again, all the Southwest are at the top here from the original Oltp queries, and that executed in about 8 seconds. And with our Approximate queries, so we executed that right here, the Approximate queries, and as you can see, Southwest is dominating it again, but it took us about 1.5 seconds to execute it, so a big speed up there. And we'll go look at the what airlines arrive on schedule as a join with the reference table so we can see the actual name. So Aloha, Hawaiian, Alaska, US Airways. So let's go back and look real quick. So Aloha, Hawaiian, Alaska, Delta. So very similar. About 9 seconds there, and with the Approximate stuff, it executed in about 1 second. So you can see here this trend will continue across all of these queries. It's just a pretty significant speed up. It keeps things interactive, and that's what we're hoping for. Is we want, when data gets huge, we want people to be able to query interactively. So the final thing to demonstrate with SQL are our stream analytics. So one thing we did, we extended Spark streaming so stream definitions can be declaratively written using SQL, and you can analyze these streams using SQL. So there's no need to learn Spark streaming APIs or statically define all the rules to be executed on these streams. You just use SQL. So this gives you a pretty kind of basic overview of how we create a stream table and start the stream. And in the next section we talk about, so right along with the Approximate query processing, we package some of these synopsis data structures in SnappyData. So one of them is top K, and what it does is finds the K most popular elements in a data stream. So for example, if you're monitoring web page hits and you want to constantly know the top 100 pages on a popular website in the last 10 minutes, or like the top 10 sales regions in the last week, that's essentially what a top K data structure contains. So we talked a little bit about that, how we create a top K table. That's pretty straightforward. So anyways, to start this example, the first thing we want to do is we're going to create a file stream table that listens on a folder, and then we're going to start the streaming context. So this is not exactly how it has to work. In fact, we have some info here on how to do this with the live Twitter stream, but we're going to do it with a simulated Twitter stream. So let's go ahead and run that. So we've got that going. Now in another terminal, we're going to simulate the Twitter stream by copying tweets in the folder on which the file stream table is listening. So let's do that over here. Let's change the directory. And there that starts going. So now let's we're going to query the current batch with this file streaming query. So let's do that here. So you can see this is just, from the stuff that's coming out of that file right now, and it gives you the time it took. So first we get the top 10 popular hashtags. So that's the top K query we were talking about. You can see them here, the tag count. So that's all being managed by that top K structure and the time it took to do that. Get the top 10 popular retweets, same thing, another top K structure that's maintaining all of that. You can see all that here. And the top K hashtags, we've got that here too as well. We've got this streaming going from a file, and you can just run SQL queries, Oltp queries on that stream and you don't have to know anything about how Spark streaming works to do that. So for the SQL section, that pretty much concludes the getting started. The next section is on the Spark API, and I'll do a separate video for that. But just to cover some of the high-level points, you know, in streaming you parallelly ingest data, and that you model the streams as if they're tables, and you just run queries on them as if they're SQL tables. So that's pretty simple. A lot of people know how to do that. And so I hope this video has shown the value of what we've done in the getting started here a little better. And make sure, if you're interested in the Spark side of things, to watch the next video. So with that, I hope you enjoy Snappy. Go check out our site at www.snappydata.io and check out our blog. We have a bunch of community channels, as shown in the GitHub here. So you can come talk to us pretty easily. And we'll all be on those channels responding to questions. Check out our blog, and follow us on social media. So check out the next video if you're interested in the Spark stuff.